Section 7.2 is all about rational exponents. And remember that rational numbers are numbers that can be expressed as a fraction or as a quotient. So that's not something we've seen before. So let me explain to you where those come from. So we learned in section 7.1 that square roots kind of undo squares, right? The square root of 7 squared is 7. The square root of 3 squared is 3. We also learned when we were talking about exponents that if I have an exponent raised to another exponent, I multiply them together. So if I had 3 squared, what would I need to multiply it by to get back to 3 where I was before? Well, what's going to have to be x is 2 inverse, which is 1/2. 3 squared times 1/2 equals 3 to the 1, which is 1, right? So this rational exponent essentially undid the square. I'm making a lot of quotation marks to myself, and I don't know why. But this 1/2 undid that power of 2. So let's talk about rational exponents, right? Let's say that the nth root of a is a real number. Then a to the 1 over n is equivalent to the nth root of a. So for example, if I have the cube root of 27, that's the same as 27 to the 1/3, which is 3, right? We could solve that. If I have the 4th root of, I was about to say 16, but I already have that number down there, 625, that's going to be 625 to the 1/4, which would give me 5. So you don't have to rewrite rational exponents as a square root in order to solve them. If you already know that, 4 to the 1/2 is 2, you can skip this step. This is just to make sure we're all on the same page, keeping up with the fact that rational exponents are roots. So if I have negative 16 to the 1/4, that's negative the 4 to the square root of 16th, which is negative 2. Now you might be asking, why is that negative on the outside? Why is it not attached to the 16? Well, if I'd had negative 16 to the 1/4, then it's telling me I want to take the 4th root of negative 16. It's not just the negative root. And I'd get the 4th root of 16, negative 16, which does not exist, is a complex number. And we're going to see that in section 7.7. If I have x to the 1/3, that's the cube root of x, which, because we don't know what x is, we can't solve any further. So let's go ahead and solve the rational exponent. So if I have 100 to the 1/2, that's the square root of 100, which is 10. Again, you don't have to do this middle step, but I'm going to. If I have 64 to the 1/3, that's the cube root of 64, which is 4. If I have negative square root of 256, that is the 4th root of 256. That gives me negative 4. And if I have negative 32 to the 1/5, that's the 5th root of negative 32, which is just going to be a negative 2, because negative 2 to the 5th is negative 32. All right, so that's how we're going to be solving rational exponents. Now, let's say our numerator isn't 1. Then it's not so nice. It's not clearly a root, right? If I have a to the m over n, this means I could pull out a factor of m, right? So I have a to the 1 over n to the m power. So essentially I'm taking the nth root of a to the m power. So here I'd have 36 to the 1/2 cubed, which is the square root of 36 cubed, which would give me 6 cubed. Now, I'm not going to expand that one out because I don't know that off the top of my head. On exam, don't feel like you have to plug this into your calculator and write this as a real number. 6 cubed is equivalent to whatever it is when you plug it into your calculator. If I have 125 to the 2/3, that's 125 to the 1/3 squared, which is the cube root of 125 squared, which is 5 squared, which is 25. See, I know what that one is off the top of my head, so I went ahead and wrote it down. Now I have negative 4 to the 5/2. So I have negative 4 to the 1/2. That negative's not attached. This one is because parentheses. This one isn't because no parentheses. Negative 4 to the 1/2 to the 5th power. So here I have negative square root of 4 to the 5th, which is negative 2 to the 5th, which gives me negative 32. If I have negative 27 to the 2/3, that negative's coming with me, so I've got negative 27 to the 1/3 power squared. So I have the cube root of negative 27 squared, which is negative 3 squared, which is 9. And then I had these examples in class, which I didn't find incredibly helpful, so I'm going to skip those because they really don't work very nicely.